Benzene electrophilic substitution reactions. Now, we've been talking about benzene a lot and how it's very stable and doesn't react. So what are we talking about now? It's doing a reaction with it. So first of all, it's very slow. And then second of all, we have to heat it up and give it acid. So heat anything up with acid. Acid is the standard catalyst for anything. And you can get a reaction to occur. So you can see here, it takes a while to get this sort of unstable carbocation intermediate with heat and acid, so a fair bit of effort. And once you've got that, you can actually get the hydrogen to pop off to give a more stable product, which is nitrobenzene product. So this is the general pattern of how it works. You basically get some sort of instability for some reason, and so there's some sort of concentration of electrons somewhere in the ring. And so therefore an electrophile, something positive, is attracted to it, and then you get this carbocation forming, and then the H plus can pop off. Okay, so that's the general rule. Now we're going to just do it specifically with nitrogen, and so you're going to have to learn this. Okay, so basically this NO2 plus comes along. We'll talk about that in a sec. This is the bit you have to know. And so that's the one that joins up to stable carbocation, and then very quickly goes to nitrobenzene, which is over there. And then the H plus pops off over here. All right, the bits in red were specifically in a previous IB test. And so that was in the mark scheme. So they were looking for the H plus coming off. The full arrow to the nitronium ion, the full arrow to the ring, an unsettled ring with a positive charge in the middle. Okay, so the bit you don't have to know, which I'm just going to give to you just for background, is if you look at the sulfur and nitric acid, sulfur is far better at releasing its hydrogen ions than nitric acid is, even though they're both strong acids. And so when you have this situation here, you're still going to have it acting like a Bronsted-Lowry base, and you're still going to have a transfer like this, and then you've got a H2NO3 plus. And so it looks like this, and that can very easily pop off to be water. And there you go, you got your nitronium ion, which is what you need. You need this NO2 plus ion for this reaction to occur. Now, once that reaction has occurred and the H plus has come off, the H plus can then go back to here. And so that's why it's a catalyst, because it doesn't get used up in the reaction, but it catalyzes it and helps it to happen. Okay, so you used to have to know that, the formation of the nitronium ions, so the mechanism was quite complicated indeed, but they got rid of this bit. You just have to remember there's an NO2 plus to start it off, and that's it. So just pay attention to this and copy it out without looking, and do it again until you can do it without looking.